Imagine waking up one day and realizing that everything you know, your friends, your memories, the universe itself might be nothing more than lines of code. The simulation hypothesis suggests that our reality could be a sophisticated program crafted by a civilization far more advanced than our own. From the precise tuning of universal constants to the bizarre quirks of quantum mechanics, there are hints that our world might be less organic and more algorithmic than we ever imagined. But if we are living in a simulation, what does that mean for free will, consciousness, or even the meaning of existence itself? The idea that our world is an illusion has roots in ancient philosophy, from Plato's allegory of the cave to the dream arguments of philosophers like Zhuangzi and René Descartes. However, in the 21st century, this age-old question has been given a modern, technological twist. Popularized by thinkers like Oxford philosopher Nick Bostrom, the simulation hypothesis proposes that our entire universe, from the smallest subatomic particle to the largest galactic supercluster, could be a meticulously crafted computer simulation. This isn't just a plot for science fiction movies. It's a serious proposition being debated by physicists, cosmologists, and philosophers. The hypothesis forces us to confront the possibility that the fundamental fabric of reality is not physical matter and energy, but pure information. It asks us to consider whether we are biological beings in a base reality or simulated consciousnesses running on a cosmic hard drive, created by entities whose capabilities and motivations are completely beyond our comprehension. The implications are staggering, challenging our most fundamental assumptions about who we are and the nature of the cosmos we inhabit. One of the most compelling arguments for the simulation hypothesis stems from a simple extrapolation of our own technological progress. Consider the trajectory of computing power over the last few decades. We've gone from rudimentary pixelated games like *Pong* to creating vast, photorealistic open-world video games and complex scientific simulations that model everything from climate change to the formation of galaxies. Given this exponential growth, it seems plausible that a civilization only a few thousand or a million years more advanced than our own would possess computational power far beyond our wildest dreams. Such a civilization could, in theory, run what are known as ancestor simulations, highly detailed simulations of their own evolutionary past, complete with conscious, sentient beings who are completely unaware that their reality is an artificial construct. They would be born, live their lives, and develop their own civilizations, all within this simulated universe, never suspecting the truth. This leads directly to the probability argument, which is perhaps the cornerstone of Bostrom's thesis. The logic unfolds in three possible scenarios. First, it is possible that any civilization advanced enough to create such simulations will inevitably destroy itself before reaching that technological stage. Second, it's possible that advanced civilizations simply lose interest in running these kinds of simulations, perhaps for ethical reasons or because they find other pursuits more compelling. The third possibility, however, is that civilizations reach this stage and run a vast number of these simulations. If this third scenario is true, then the number of simulated realities would vastly outnumber the one base reality. Simple statistics would then suggest that it is overwhelmingly more probable that we are living in one of these countless simulations rather than the single, original universe. In this view, our existence as a non-simulated, real civilization would be an extraordinary statistical anomaly. The very fact that we are here, asking these questions, could be a data point in a simulated history. Further fuel for the hypothesis comes from the very laws that govern our universe. Physicists have long been puzzled by the fact that many fundamental constants of nature, like the strength of gravity, the mass of an electron, or the cosmological constant, appear to be fine-tuned for life to exist. If these values were even slightly different, stars wouldn't form, atoms would be unstable, and the complex chemistry required for biology would be impossible. In a natural, undesigned universe, this exquisite fine-tuning seems like an incredible coincidence. However, in a simulated universe, it makes perfect sense. A programmer would deliberately set these parameters to the exact values needed to ensure the simulation develops in the desired way in this case, producing a universe capable of supporting intelligent observers. The mathematical elegance and consistency of physical laws, often expressible in relatively simple equations, could also be seen as evidence. A universe built on code would naturally be governed by clear, logical, and mathematical rules, much like the one we observe. The strangeness of the quantum world also provides intriguing, albeit speculative, support for the simulation hypothesis. At the subatomic level, reality behaves in ways that defy our classical intuition. Particles like electrons can exist in multiple places at once, a state known as superposition, until they are measured or observed, at which point their state collapses into a single, definite outcome. This observer effect is bizarre. Why would the act of looking at something change its fundamental nature? One analogy from the world of computing offers a compelling explanation. In video games, the game world is not fully rendered all at once. To save processing power, the game engine only renders the parts of the world that the player is currently looking at. The environment behind the player or beyond the horizon exists only as simplified data until it enters the player's field of view. Could the universe be operating on a similar principle of resource optimization? Perhaps reality only becomes definite and rendered when a conscious observer interacts with it, saving the cosmic computer from having to simulate every particle in the universe in full detail at all times. This would also explain other quantum phenomena, like the idea that there's the smallest possible unit of length, time, and space, the Planck length. A digital reality would necessarily be pixelated at some fundamental level, and these quantum limits might just be the resolution of our simulated universe. Of course, contemplating life within a simulation immediately plunges us into deep philosophical waters, most notably concerning the nature of free will. If our universe is a program, are our choices truly our own? Or are they predetermined by the simulation's code? It's possible that we are like non-player characters and NPCs in a game, following a script with only the illusion of agency. Our every thought, feeling, and decision could be the inevitable output of a complex algorithm. Alternatively, the simulation might be more like a sandbox, where the creators set the initial conditions and physical laws, but allow the simulated inhabitants genuine freedom to act within those rules. In this case, our free will would be real, but constrained by the physics of our simulated world. The answer could depend entirely on the purpose of the simulation. Is it a deterministic historical reenactment, or is it an open-ended experiment designed to see what emerges? The question of consciousness is equally profound. How could genuine consciousness, our subjective experience of joy, sorrow, love, and self-awareness, arise from mere code? This touches upon the hard problem of consciousness. Some philosophers argue that consciousness is a fundamental property of the universe that can emerge from complex information processing, regardless of whether that processing happens in a biological brain or a silicon chip. If a simulation is sophisticated enough to perfectly replicate the neural patterns and structures of a human brain, it might inevitably give rise to the same conscious experience. From the inside, a simulated mind would feel just as real as a biological one. It would believe it has a physical body, experience sensory inputs, and form memories, completely unaware that its entire existence is an intricate dance of data. The very nature of our self-awareness might not depend on the substrate it runs on, but on the complexity and structure of the information itself. Despite the tantalizing arguments, it's crucial to acknowledge that the simulation hypothesis remains firmly in the realm of speculation. As of now, there is no direct, verifiable evidence to support it. Many critics, including prominent physicists and philosophers, argue that the hypothesis is fundamentally unscientific because it is unfalsifiable. A good scientific theory must make testable predictions that could, in principle, be proven wrong. But how could we ever definitively prove we are not in a simulation? Any evidence we might find, any experiment we could conduct, would itself be part of the simulation. The creators could easily alter the rules or erase our memories to prevent us from discovering the truth. The argument from probability has also been criticized as being based on too many unprovable assumptions about the behavior of hypothetical advanced civilizations. We have no data on how such civilizations would act, making any statistical claim a shot in the dark. It is, for now, a philosophical argument masquerading as a scientific one. Nevertheless, the mere possibility that we are living in a simulation forces us to confront some of the most profound questions about our existence. If our reality is artificial, does that diminish the meaning of our lives? Do our struggles, achievements, and relationships lose their value if they are simply part of a program? Many would argue no. The love we feel for our family, the beauty we see in a sunset, and the satisfaction we get from our work are all real experiences to us regardless of the ultimate nature of the reality in which they occur. The discovery that we are in a simulation could, however, revolutionize every aspect of human thought. Science would be transformed into a kind of reverse engineering, an attempt to understand the code of our universe and perhaps even find glitches or backdoors. Religion might be reinterpreted, with the simulators seen as our creators or gods. The ethical implications would be enormous. If we could confirm the simulation, would we have a moral obligation to try to contact our creators? What if our universe is just one of many, and its purpose is something trivial or even malevolent from the perspective of its architects? The journey into the simulation hypothesis is a mind-bending exploration of the ultimate nature of reality. It challenges us to think beyond the confines of our perceived world and to question the very fabric of our existence. While we may never find a definitive answer, the pursuit of this question expands the horizons of human imagination and reinforces a fundamental truth. The universe is far stranger and more mysterious than we can possibly comprehend.